Hello everyone and welcome to the lecture on AWS Lambda. So AWS Lambda, Serverless Compute Service. AWS Lambda is a service offered by Amazon Web Services that allows you to run code without provisioning or managing servers, and this is called a serverless model. Event-driven architecture. AWS Lambda is designed to be event-driven, meaning it executes code in response to certain events like changes to data in AWS services or HTTP request via API gateway. Scalability. Lambda automatically scales up or down as many copies of the function as needed to handle the rate of incoming events. You don't have to manually adjust the scale. Cost efficiency. With Lambda, you pay only for the compute time you consume. You are charged based on the number of requests for your functions and the time your code executes. AWS services integration. Lambda can be integrated with various AWS services like S3, DynamoDB, and SNS to enable diverse use cases ranging from data processing to real-time file processing. How AWS Lambda works. Trigger event. AWS Lambda functions are executed in response to triggers such as a file upload to S3, a new log file in CloudWatch, or a new row in DynamoDB. Function invocation. Once triggered, the function is invoked. AWS provides SDKs and APIs to manually invoke the function as well. Execution environment. AWS Lambda automatically provides the computing resources such as memory and CPU required to run the function. The environment is isolated and secure. Statelessness. Lambda functions are stateless, meaning they do not retain the state between invocations. For maintaining state, external services like Amazon RDS or DynamoDB must be used. Output and logging. The function's output can be stored directly to AWS services such as S3, or it can be used as input to another Lambda functions. Logs are managed via Amazon CloudWatch. So this is a one diagram which is for serverless website. So if a user make a HTTP request, you can put an Amazon API gateway which will invoke an AWS Lambda function, and that will read and write from Amazon DynamoDB, which is again serverless, and finally to make a read and write, it will check whether it is authenticated or not. Then it will redirect to Amazon Cognito. This will pass you a token, and then you can read and write from Amazon DynamoDB, and then AWS Lambda will respond back with the HTTP response, and then that can be served by the API gateway to the user. So use cases of AWS Lambda. Real-time data processing. Lambda can be used to process real-time data from sources like IoT devices, instantly analyze and take action. Backend for mobile and web apps. Lambda acts as a scalable, serverless backend for mobile and web application, easily connecting with databases. Schedule tasks. You can schedule tasks like data backups or cleanups without the need for a permanent server. Serverless data transformation. Lambda can automatically convert and move data between different storage formats and services. Supported languages in AWS Lambda. Node.js. Lambda supports multiple versions of Node.js. Python 2.7 and 3.6 plus are supported. Java 8 and Java 11 can be used. C#. .NET Core is available for C# workloads. Go. The Go runtime is supported. Ruby is also available, and any custom runtime you can use. You can even use a custom runtime if the standard ones do not meet your needs. Now, different triggers available in Lambda. Amazon S3 triggers when a new file is uploaded to a S3 bucket. API gateway. HTTP triggered by HTTP request through API gateway. CloudWatch activated by CloudWatch alarms or logs. DynamoDB streams trigger when a new record is added to a DynamoDB table. Kinesis triggers from Kinesis streams for real-time data processing. SQS activated by messages in an SQS queue. SNS can be triggered by SNS notification. So we'll just see some AWS Lambda integrations. Amazon S3. Lambda can automatically execute code when files are uploaded or deleted in S3, making it useful for data processing pipelines. Amazon DynamoDB. Lambda can respond to DynamoDB stream events, enabling real-time data manipulation. Amazon RDS. Although not directly integrated, Lambda functions can connect to RDS instances, which allows for complex queries and data manipulation. Amazon Kinesis. Lambda is often used for real-time data analytics with Kinesis streams. Amazon SQS. Lambda functions can be triggered by new messages in SQS queue for asynchronous processing. Some more AWS Lambda integration part 2. Amazon SNS. Lambda can subscribe to SNS topics to handle distributed messages. AWS step functions. Lambda can be integrated into step functions for complex workflows that involve various AWS services. Amazon OpenSearch. AWS Lambda can ingest data into OpenSearch and trigger indexing, making it ideal for creating real-time searchable indexes. Amazon Redshift. Lambda can execute SQL queries in Redshift, facilitating data ingestion, transformation, and analysis in data warehouse. AWS Data Pipeline. Lambda can act as a data node within the data pipeline, enabling complex ETL processes that involve multiple AWS services. Availability, scalability, and performance of AWS Lambda. High availability. AWS Lambda is designed for high availability with redundancy and backup across multiple data centers. This ensures that your functions are always available for execution. Auto scaling. One of the significant advantages of AWS Lambda is its auto scaling feature. Lambda automatically scales the function execution in response to traffic. Low latency. AWS Lambda function is optimized for fast execution and low latency, making it ideal for real-time processing tasks. Fault tolerance. Lambda has built-in fault tolerance. AWS takes care of maintaining the compute capacity and infrastructure reliability. Global reach. Lambda functions can be deployed globally, close to the end user in various AWS regions to minimize latency. And that's all. Thanks for watching.